is ready. Good morning, everyone. I'm Dr. Valaipon, and I'm so happy to be your host for this public lecture event. And we are so fortunate to have one of the most prominent figures in artificial intelligence and architecture giving us a lecture today. Which at first it was to be for a class of an international master program in architecture. The class is called Current Issue in International Practice. But once I have posted the announcement on Facebook page, everybody just wanted to get in. So I was reluctant at first, but then Matias started to share this lecture, and he said, come join me, blah, 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 actually I'm gone. So okay, he allows us to have this as a public lecture. Okay, so thank you, Matias, so much. First, okay, I will just introduce a little bit. Maybe you have seen him from a webinar that Kunkit and TFMA hosted last year. And he is a Chilean-Austrian who has graduated his master's degree from the University of Applied Art, Vienna. And then he has done his PhD at RMIT in Australia. And together with his wife, Sandra Menger, who is also Austrian, they founded a design studio called SPAN. And then they both moved to the United States to teach at the University of Michigan. For a couple of years, they have founded a research lab over there. And just the end of this year, Matias Sandra has moved further, but Matias just moved to New York Institute of Technology, which he just started his first year in New York. Okay, so I met Matias in 2018 at Digital Future Workshop in Shanghai, and he was wearing some kind of head-mounted display, doing some weird thing with mixed reality, so all weird stuff. But then he started to build his reputation in AI, and we have maybe some of you have seen or have read his book called Neural Architecture. Okay, and a couple of years back, our international program, INDA, has invited him to give a lecture about AI in architecture. And I believe that at that moment, many people didn't realize what they may have questioned what artificial intelligence has got to do with architecture. But today we see more of that coming. Okay. So happy for you to invite, I'd like to invite Matias del Campo.
Hello everybody, can you hear me? Is the microphone working? Yes? There's also one here, can you hear this? I'll take this. All right. I think this one works, yes. All right. Hello everybody, Valaipon, thank you so much for the generous introduction of myself and for the invitation to talk today to you. Yes, we have known each other for quite a while now, and it was an interesting journey, like seeing how certain technologies started to affect architecture. Today, I'm going to try to somehow wrap AI around what it means for architecture, for the architecture discipline, why I think it's important to deal with it, why I think it's important to take it in as a possibility in architectural design, and how much it is involved already in our everyday life. So I think there is one unmistakable truth at the moment, which is AI is here. It's not science fiction, it's nothing for the future, it's something that is currently already all around us, influencing our lives, also of course the ways we design. And so now what? Yeah? If it's here, what does it mean for the next steps in our discipline? Let's start with something that sounds kind of simple, but I still think it's important to talk about. What is AI, generally speaking? I think there's a lot of confusion around that term. There's a lot of things going around. In fact, AI is not one thing. It is many things. It is many different algorithms, many concepts, many mathematical models, and they're all somehow influencing a large set of possibilities of machines learning about a variety of aspects, and all of those together we call artificial intelligence. So there's not one artificial intelligence. It's like talking and saying there's just one economy, when economy is actually constructed of a huge set of different things that come together to form that term. So those things can be subsumized in machine learning, natural language processing, speech processing, and vision. These are like the main branches. I don't know if you've heard about an author called Pedro Domingos. Pedro Domingos wrote a book, 2015, called The Master Algorithm. I can really recommend that book to anyone who wants to know like the basics of any AI system. He basically identified 5 different tribes of concepts in AI. Symbolism, connectionism, analogizers, Bayesian algorithms, evolutionary algorithms. You might have heard, for example, about genetic algorithms. Carl Chu worked with those already decades ago. It is considered part of AI. Symbolism basically understands how semantic information is perceived by machines. Connectionism is like this famous branch that brought about neural algorithms. And all of that, again, is subsumized in AI. The most successful model at the moment is probably connectionism, neural networks. This is what we see the vast majority of things happening around us. No matter if it's facial recognition or designing architecture, they're all based on a similar idea, which is basically simulating or emulating processes in our brain, putting that into mathematical algorithms, and then using them in machines. So that's basically how we can teach machines, for example, to recognize doors, windows, faces, shoes, whatever it is. We train them to understand or to see them and then recognize them. I just mentioned a little word called understand, and that's a mistake of mine. Actually, AI does not understand anything. Yeah? Not the way we humans understand things, because we as humans understand the symbolic context around us, right? We know we're sitting on a chair in a lecture room in a library that has books that have content that is important to us, right? We understand that. And AI does not understand that relationship, the context of itself. It understands there's a book, kind of understand. It recognizes pixels that look like a book, yeah? But it does not understand a book has content and meaning and text and poetry. No clue about that. So whenever you think that AI understands anything, wipe that thought away. It's a machine that can recognize pixels and numbers. That's it. But it can provide very interesting things. Like, for example, this is a list of possible applications in architecture that I got out of ChatGPT. Just asking, how can I use AI in architecture? You get a list. The list I get is not because it understands how important architecture is. I get the list because it's very well trained in predicting the probability of the next word in the sentence that it spits out. So it's pure mathematics, but still it provides very interesting insights for us humans to interpret, work, and use. Another question, why use AI, right? How many of you have asked yourselves why you're interested in AI? There's a rather you can simplify it a lot. You can basically say it's better to teach machines how to learn instead of how to do things. It's better to teach machines how to learn instead of how to do things. Like, what do I mean by that? I'm sure you have seen videos like this before. This is basically how cars were made from the beginning of car making until the late 1960s. A set of experts knowing what they're doing, putting pieces together to form a car. So welding, painting, bending carrosseries. These were people doing that, right? And they were all experts. With experience, they get better and better and better. Yeah? In 1961, the first industrial robot was introduced to car manufacturing by General Motors. It was called the the LM1. And it was basically designed to weld cars. And then like a couple of years later, this is like maybe 10 years later, 71 to 75, Japanese companies specifically started to introduce robotics in assembly lines. However, there's a disadvantage for these assembly lines. Every time you make a new car model, a person has to retrain the robot for the specific welding points in space of that car. This training is very expensive. That's why they produce like thousands and 10,000s of the same car to somehow compensate for the cost of training and programming. This also means that the car industry collected millions of data points of welding points in space for a car. We have those data sets, yeah? Which means now I can take that data set and train a machine not about specific points in space, but I can train the machine what is good welding. Combined with machine vision, it means that every single car that comes along that assembly line can be different. And the machine still would know where to weld it together, optimized. This is what I mean by we are teaching machines how to learn instead of how to do specific things. And you can translate it to anything, including architecture. All right, I'm going to do a little jump now. The impact of AI on human culture, on our own culture. What does it mean if we have machines that learn in the context of our own existence as humans? Throughout the last couple of years, we have seen already a huge impact of artificial intelligence on a variety of different art forms. Visual arts, video, music, poetry, even dance. Yeah? And of course, there's been also very critical interrogation of AI. Like, for example, Kate Crawford's Atlas of AI discusses that working with AI does not mean just some mysterious computer in the cloud. There is also, you have to get the materials to make a machine. You have to excavate for rare earths and things like that basically are used in making computers. So there's a very direct material impact of AI. We need more energy to run AI. Energy consumption has gone up in the last couple of years considerably because of the use of artificial intelligence. Where does this energy come from? Yeah. Then other things, like, for example, there was a Race After Technology by Ruha Benjamin. Like, how do we deal with the biases in all the data sets we're using, right? That at the beginning of AI, facial recognition, for example, had no problem recognizing white faces, but it was not able to identify people of color because the data sets were so small about people of color. Yeah? So there's racial biases, there's gender biases, but I'm going to talk about this in a minute more. What is undeniable is that AI is not like a singular small occurrence in our history. It has an enormous impact on our culture at large. So it's nothing that only affects architecture, like parametricism. Like the term that Patrick Schumacher so beautifully threw around is basically only interesting for architects. AI is general, a general cultural shift in what we're doing and how we're doing culture. So another question, does AI affect architecture? What you see here is a diagram of a statistic that was published by Goldman Sachs in March 2023. So it's already almost 2 years old. Yeah? It actually demonstrates the impact of AI to a variety of different disciplines. The red stripe is architecture. And if you look at the numbers, it means that 37% of the jobs are affected by AI within the next 10 years. 300 million jobs worldwide. We are certainly more affected than other disciplines. 37%. That's a lot. Yeah? But what it means is not that those jobs will disappear. They just will change. Yeah? This is something you have to keep in mind. This has happened in architecture before. It's nothing new. We adapt to new technology, the job starts to change. I mean, last time this happened was in the early 90s when computers somehow made their first big impact. We changed from drawing plans on paper to drawing plans on the computer. Now we're experiencing something similar. It's a little bit more widespread because it affects so many different areas of humanity. But we just will, as usual, architects will adapt, yeah, and adapt to that condition. More deeply is the question, how can we shape as architects the discourse around it? We have to be aware that technology also means changes in our discourse. Historically speaking, for architecture, every time a new technology or a new insight came into play, our own thinking about what space means, what organization means, what materiality means, changed. Yeah? No matter if this is in the Renaissance or in early modernism or when computation came along. We change how we think about space and material and fabrication and making. This will, of course, also be true for now. And what myself and others have been doing is providing a platform about the discursive impact of architecture. What does it mean for the ontology of designing? What does it mean for the epistemology of space? What does it mean for the history, in the context of the history of architecture? I think it's important not to only consider AI a technical tool. It's a tool, as I mentioned, that has an impact on human culture. And architecture, as part of that human culture, of course, needs to discuss this. We need to talk about what it means when machines suddenly can automatically create sections, right? Plans, can remix our whole history of architecture. Yeah? So to do this, I've created like a series of publications and conferences and exhibitions with a variety of other people that discusses all those topics. And I have the feeling we're in the middle of it. We are not, or even at the beginning maybe of that discussion. Yeah? There's going to be much, much more that we will take out of these new technologies that informs us as architects about our own cultural contribution to humanity. I think it's important to understand that. So to do this, I've done things like this Neural Architecture Exhibition and Symposium at the University of Michigan, Taubman College. This was in November 2022. And then also very important, Data Justice, AI and Design, which was a symposium which was particularly interested in understanding how this new technology deals with biases and how we can try as a discipline to counteract to that. The advantage of architects is that we're so late in the game of AI that we still can shape how those data sets are formed. Versus other disciplines who have been doing data sets for the last 40, 50 years have already those biases deeply ingrained in what they do. So we still can change that. I think it's important that we understand that as architects. Now for another concept that I think is highly interesting in regards of AI is things like estrangement and defamiliarization. These are, as AI is based, sorry, let me start again. AI, or at least neural networks, are based a lot on how our mind works, right? We understand certain things like the visual cortex, perception, language. We understand a little bit how we dream. We understand a little bit how we hallucinate, yeah? And all those things can be taken and turned into mathematics, and thus we can use them as algorithms for AI. Now the funny thing is, because we understand things like hallucinations and dreamings, we can deal with things like estrangement and defamiliarization. This is a very interesting neural effect that happens in our brain, which is we see something that looks familiar to us, but is strange enough to really evoke attention. We look at it because it's interesting, it's different, it's weird, yeah? It's strange. This is a good quality. It's nothing bad. It's an interesting quality because it can provoke us as designers to design things differently, yeah? And they will still work, because they're familiar enough. Yeah? Let me show you an example for this. So this is a data set of brutalist buildings that are put together. Yeah? And this is a so-called latent walk. It's already pretty old. I think we did this 2020. But you still recognize the building, right? You recognize the door frames, the window frames. You somehow recognize the features of a brutalist building. On the other side is the same data set, but what I did was I intentionally polluted the data set, meaning instead of having just buildings of brutalist design, I threw in a bunch of Picasso paintings on top of it. And now the machine is confused. Is it now a painting or is it a building? And exactly these are the things, and suddenly things happen that are interesting, provoking, different, exciting, and I take this as an inspiration for further design. Now, estrangement, defamiliarization is not a completely new concept. Hegel talked about this, Marx talked famously about the estrangement of the worker, for example. Viktor Shklovsky wrote a paper in 1917 called Art as Technique, where he wrote about estrangement as a method to evoke attention with the viewer. So there is like, it's a pretty old concept. Yeah? Bertolt Brecht famously used the methods of estrangement in his theater plays. Yeah? So all this idea, all this history of estrangement and defamiliarization helps, for example, me as in terms of theory to create a ground that is not like completely divorced from our history in theory and philosophy, but is part of that. And I think when you talk about AI and the way how AI works, because it always works with existing knowledge, it's important to understand that you can position that idea and technology within a larger framework of historic dimension. Famously also, Sigmund Freud wrote another paper called Das Unheimliche, the uncanny. And he talked about similar qualities than other authors describe, which is you see something that is familiar to you, but there's enough strangeness in there to evoke your attention. An example would be H.P. Lovecraft, who wrote, for example, very often in an uncanny way. Yeah? For example, he describes how a person, an actor in his writings, meets his cousin. And the cousin looks like always, very usual, like same clothing, same face, looks the same. But then the cousin starts talking, and the voice is completely different, strange, weird, satanic, whatever he wants to write, H.P. Lovecraft. That actually creates this moment of estrangement. You see your cousin, he looks familiar, you know him, but the voice is completely different. And that happens in architecture too. This is an example for that. This is also an older Midjourney image. I honestly, by the way, like the older versions better because they're a little bit more strange. But as an architect, you recognize features here immediately, modern features. You know, cantilevering, ribbon windows, the specific mullions and frames. Even the tinting of the glass somehow looks kind of familiar. So these are the familiar aspects. You know that. You know that. You've seen this a million times. But then you start to look closer. What happened to the roofline? Is it designed like that? Is it broken? Was it destroyed? Like you start to ask yourself questions about that. Or the relationship to the ground. What's happening there? It looks like it's carved from one block, or is it just messy construction? You don't know. You don't know, was this intentionally designed like that, or did it happen at some point? This is estrangement. This is defamiliarization. You see something that is familiar to you, like the cantilevering, the ribbon windows, and then there's elements in there that are, what's going on there? Why does it look like that? And that, I think, are moments that we can appropriate and use them for the design. So I get this result out of Midjourney, I'm like, yeah, I kind of like it. It's interesting, it's different. The rise of neural art. So the predecessor to a lot of the conversations I do around AI happened already in the art before. Arts are always a little bit faster than architects, sometimes a lot faster than architects in catching up and getting things that are interesting and exciting. You might have seen this painting before. This is the portrait of Edmond de Bellamy by the Paris-based art collective Obvious. And the reason why this became famous is, first of all, the art group basically said that that's the first AI-generated piece of art. I highly doubt it, but it's a good story. And then, on the other hand, it became famous because it sold for $430,500 at Christie's in London. Yeah? This was like a huge splash. Like everyone was like, really? AI can make art and it can be that expensive? If you look at the lower right corner, the signature on the painting is just one part of the StyleGAN 2 algorithm that was used to create this. Apart from it being expensive and maybe the first AI art piece, there's more interesting things here. One of them is the question of agency. Like, who created this piece of art? Was it the art collective that came up with the idea to use AI? Was it the programmer who actually programmed the StyleGAN 2 algorithm, because it was not programmed by the artists? Or is it all the paintings used in the data set to create the painting? Thousands of thousands other artists. So who is the author here? Yeah, it's completely not clear. Which actually leads to the question, what means agency and authorship today at all? Another one, what kind of sensibility was created now with this artwork? Is it a new sensibility? Is it something really different? Or is it still so close to, for example, Dutch master paintings from the 16th century that it can be considered like an imitation of 16th century painting? In my opinion, it's something different. It's again this idea of estrangement. Yes, we can see that obviously Dutch master portraits from the 16th century were in the dataset, like typical black clothing, it's very Dutch, yeah? The way of the composition, the color of the face. So all the things look familiar from these paintings we know. But it's still strange enough to look interesting. Like the eyes are strange, you barely can recognize mouth and nose. You can do this with architecture too. I mentioned already authorship, yeah? Which is a big question that needs to be resolved at some point now. I actually wrote recently an article for AD where I made the argument that authorship may have died already. Yeah? That this whole idea of singular authorship for a singular piece of art or even architecture has become obsolete through the generalization that exists through using large data sets in AI. And honestly, in architecture, probably that already died a while ago because no one of us designs a building alone or builds a building alone. It's always a collective work. There's other interesting artists out there like Sofia Crespo, who actually makes her own data sets. Yeah? Or Mario Klingemann, which I think is an amazing AI artist from Germany, who also, again, makes his own algorithms and data sets. What this tells me is that we as architects at least should understand how to operate with an AI system by creating our own data sets, maybe using specific algorithms. I'm not saying you have to start learning Python, maybe a little bit, yeah? At least enough to understand how it works and how you change things, yeah? But you're not supposed to become like programmers. It's like in our own architecture education, you learn enough about structural engineering that you can go to a structural engineer and talk to him about your idea. And I think the same we have to learn about programming, scripting, and so on. You have to know enough about it that you can go to a really professional computer scientist and tell him, here's a sketch of an idea I would like to do, help me do that. It saves you also a lot of time, I tell you. I tried to do it myself, yeah? And then I figured out, why am I wasting my time like trying to script something for a week that barely works if I can go over the street to my computer science friends and tell them, this is my idea, and 3 hours later they're finished. Okay, you save a lot of time. That's what I'm trying to say. Okay, let me jump over this. Around the same time when Mario Klingemann, Sofia Crespo started to do their work, we started to also play around with data sets of Gothic architecture, for example, and seeing like what happens if we pollute the data set, if we like completely turn up the weights in the algorithm so that they do like weird stuff. I was really happy about the results we got out of that. It was very, very useful for us. But at the same time also, all the things that happened around 2019, 20, during COVID, like I spent tons of time during COVID just doing data sets because I was sitting at home doing nothing. Some interesting questions came up. And I touched on this already a little bit. The problems that come along with dataset building are really important because there's racial bias in datasets. I mentioned before this example of early facial recognition that was not able to recognize people of color because people of color were not represented in the dataset. The other one is cultural bias. What happens with cultures, human cultures that do not have an image tradition, for example? Right? They're almost immediately excluded of being within a system that recognizes or works with all aspects of humanity, not just a couple. Yeah? And then, of course, gender bias. Yeah? This is also incredibly present. Like, I remember early Midjourney versions when you started to type in random numbers and letters instead of a real prompt. What Midjourney did was it created an image out of the largest elements it has in the data set automatically. What happened? You got pretty white young girls. That's what you got as a result. So this meant that that was the biggest part of the data set was made of pretty young white girls. So not representing anybody else, which is a form of gender bias. This means that labeling data at the end of the day is a political act. Yeah? Coffee time. So how do we as architects fit into this whole universe of cultural development, technological frenzy that's happening right now? How do we use that? Yeah. In, I think, 2019, yes, it says up there, 2019 is the first time that we tried to generate sections and plans using AI. And I was super excited. I was like, oh, that's so cool. They're automatically creating sections. They look so amazing. Wow, we can automatize architecture completely. Yes. Yeah. And then I started to look a little bit closer what these sections do and what these plans do. And I figured out they make no sense whatsoever. Yeah. There's rooms without doors, rooms without windows, staircases that go nowhere. The reason why this happens is because we were using StyleGun 2 for this. And I mentioned at the beginning the problem of semantic information, meaning that, or understanding. You remember? Understanding, like AI doesn't understand anything. I mentioned this. This is exactly an example for that. It does not understand that it's making architecture. It's just imitating something that looks like a section in the dataset. Of course, we build our own datasets. We build our own section datasets. But it starts to interpolate between those without understanding the sense behind it. It does not understand what's a toilet, what's a lecture room, what's a living room. It does not understand that. It just imitates figures, pixels, and organizes them. However, I still think it's very valuable for me as a designer to get something like that section here in the middle. Because it was like, there's something there. There's something interesting there. If I continue working on it and make it work in a sensible way, I end up with something that was inspired by AI, creating something I would have not thought about as a designer that actually pushes forward my own design agenda or idea. So I like this sort of dialogue between the machine and the human. It's not about automating everything. It's about pushing the machine to give you something that will inspire you as a designer to do something different, exciting, hopefully new. The new is also a big problem with AI. I will talk about this in a minute. But it really can push your design forward and do things you did not think about. For me, working with AI is the first genuinely 21st century design method. Why do I say that? Think about computational design today. Polygon modeling, invented in the 20th century. NURBS modeling, invented in the 20th century. Parametric modeling, invented in the 20th century. Agent-based modeling existed in the 90s. Yeah? Like every single one of those things that you think is contemporary existed already in the 20th century. In the last 25 years, it was just refined, made better, optimized here and there. Yeah? The newest thing around that is basically things like Grasshopper, which came out around 2009, I think. Yeah? But it's indeed just visual scripting. So that existed already before. Working with AI, the way we can work today, did not exist even 10 years ago. Yeah? And it made massive jumps in the last 5-6 years. So this is the first time in history we as architects can use this technology to design. That's why I say it's the first 21st century design method. Something more practical. How does AI impact the AEC industry, architecture, engineering, and construction? Because it's about practice, right? So how do we affect that? Think about the life cycle of a building. So let's say it's divided into 7 aspects. Preliminary design, the design phase, planning phase, construction, maintenance of the building, and then at the end of the life cycle, demolition. Yeah? This is pretty common, we know that. So how does AI affect that? Now, we do prompting as a preliminary design method. We can do fast variations as a design period. We can use generative planning for the planning phase. We can actually use machine vision to make construction sites more safe. Yeah? We can also use machine vision in combination with AI to maintain the building, like tell people what they have to do where to repair things in the building during its life cycle. And we can use machine vision and machine learning to sort the materials on the construction site when we demolish. So basically, every single aspect of the architecture cycle, life cycle, can use artificial intelligence. Today, like what you see down here, is like a bunch of applications that can be used for that purpose. What we have currently today, like when I'm speaking here to you, the vast majority of what architects and students see is only the first two ones. So for every student here in the room, all these other aspects you see is for you to take it. It's your future. You can take that, make something amazing out of it. It's all out there. Which also brings me to a very important conclusion, which is if we do not engage with AI, somebody else will do it for us. Yeah? This means that if we as architects do not actively work on it, make it our own, the construction industry, developers, they will pick it up and they will do the work for you. So don't let that happen. Pick it up and work on it. Why do we need to demystify artificial intelligence in architecture? This touches on something I mentioned already, which is what we see today as architects, or the majority of the public, is things like ChatGPT, Midjourney, DALL-E, Stable Diffusion. But underneath that surface, there is a ton of other algorithms that allows us to apply that to design and architecture. And they're very, very useful. AI can do two things really, really well. One is prediction, and the other one is optimization. Yeah? And thus, both of those terms are perfectly applicable to architecture. Yeah? They basically, like if I want to predict, for example, the life cycle of a building, I can do this today provided I have enough data. Yeah? If I want to optimize structural engineering with AI, absolutely possible. I mean, there's like a variety of possibilities to do that. It all depends on the data that you have. That's why the data sets at the bottom of these icebergs are probably the most important part. In architecture, we're a little bit lazy with doing data sets. We're lazy with sharing data because everyone in architecture thinks, oh, that's my IP. Why should I share it? Yeah? We have to start to change that mindset because otherwise we're gonna fall behind as a discipline behind everybody else. Because everybody else, specifically in science, is doing that. They're sharing the data. Of course, every time you use the data, you have to cite the person you got it from. That's something we as a discipline have to be a little more disciplined with, because we're not. How do we develop a pedagogy around AI? How do we teach AI? Yeah? I was lucky to be invited to a panel discussion at the ACSA conference to talk about this topic, so I have a couple of slides. I have a little theory. You can divide it into three things: interrogation, integration, and interdisciplinarity. Yeah, so triple I. I call it triple I. What does it mean? The first one is about critical interrogation. Yeah? It means that students have to understand that technology equals theory. It's basically those two things influence each other. You cannot just see technology for technology's sake, and you maybe should not see only theory for the theory's sake. I think this kind of relationship between the two is what makes things really interesting. What it makes it also an intellectual task, not just a technical task. Skill building. As I mentioned before, you don't need to become a programmer, but you have to understand enough of how GitHub works, how Google Colab works, like how cloud computing works, how do you change things in an algorithm. Understand enough about it to make it your own and really adapt it to what you want to achieve as an architect. So in our RL laboratory, we have our own GitHub, we have our own Google Colabs, we share this with students, every student has access to it and can play around with it. Which I think is important to create like the context of generating interesting designs at the end. Doing things like scraping. Yeah? How do you scrape images from the internet of a specific thing, or architecture, or trees, or flowers, or whatever it is, apples. So we teach actually students how to use the tools that large social media companies are using against them. We're teaching them to use them for themselves in a way to get a little bit back of it, of the data. And sometimes just a blackboard is enough to teach AI, by the way. So this was a workshop at Syracuse University where we explained how a generative adversarial network works just on a blackboard. So you don't even need high-end computing facilities to teach AI. It's a very interesting thing. And then at the end, like how do you create 3D models out of that information? So I've basically made like a whole proposal of how to how to teach, or what's the impact of generative AI or AI generally speaking to education. Just to somehow summarize the last 5-6 years I've been teaching, 7 years that I've been teaching AI, so that other professors can benefit from it and hopefully create also their own thought around how to teach artificial intelligence. I like to combine, for example, studios and seminars. So if in the seminar we discuss the more theoretical, philosophical aspects of AI in a larger term, in the studio we apply that to the design context. Number 2 is student integration. So the second I is integration. Students really are involved in, for example, the laboratory. It's a combination between professors, PhD students, master students, and they're all from different disciplines. So the AI laboratory consisted of people from architecture, computer science, data science, and robotics. And they all work together in that laboratory and talk to each other. Another aspect of the integration of students is publications. So students are also involved in preparing and helping to put together books. They get exposed to other people's work in a more deeper way because they have to engage with the content much more than just in a class if they're really actively working on a book. Of course, not every student can participate in this. You have to select a couple of those who help as editors. They get credited, of course, for it in the book, which I think is also important for them. And the third one is being interdisciplinarity. We always get master students from computer science, data science, and robotics to join our studios to explain to students, for example, how neural networks work, how it can be applied to robotics or automated cars or whatever they're working on, and then translate that into what it means for an architectural context. Yeah, so we have like close relationships to those people, and it's really great always to have those students from computer science, for example, around to help students solve, for example, a bug in the code or things like that. So this is a set of people who have been involved so far. I thank every one of them. They have been always like super valuable in providing very important information for students. Yeah, I was recently asked, like somebody at ACSA said, who's prepared to be like part of this AI thing in architecture? Like no one. And I said, no, it's not true. I have a list here. These are all my master students from the last 5 years who graduated with me learning about AI. And I'm proud about one little fact here. Every single one of those students got a job offer before they finished. Because they were like, oh, you're into AI? You learned about AI? Pfft, I need you. Yeah, and it's gonna just become more, by the way, I think. Sorry for showing off, but it's kind of good. So how do we design with artificial intelligence? I have a couple of quick examples that I want to show. So one is the General Center in Vienna. This was a commission where we created a data set of brutalism. Yes, I like brutalism, I admit it. So this is something I do once in a while. It's an interesting project. It's a combination of a shopping mall, apartments, and offices. It's in the center of Vienna, so we created this data set, then used again a style gun 2 to train the model. And then we intentionally, by the way, sometimes tweaks the weights of the model so that it produces something that is just not just a pure imitation, but something strange. You saw that before. And then selected a couple of screenshots from these latent walks and produced something called a pixel projection. And a pixel projection basically takes the pixels of the image in 2 or 3 directions, and wherever they intersect, it starts to create mass. Yeah, it's coming right now. Exactly. So it creates this mass in the middle. It's a very simplistic way of translating something from AI into 3D. It's primitive, it's simple, it's not sophisticated. I like it because it's different. Yeah. And then after we got this 3D model, it already provided us with a lot of information also about the interior. We still had to add on things in order to make it a functional building, right? So this is the final project at the Marienhilferstraße in Vienna. We had to add a variety of elements on top of what we got as a result out of AI, but we tried to maintain as much as possible of what was already there. So this image actually shows you what we had to add. Everything that is pulled out of the building, oops, what's going on here? All right. Everything we had to, that is pulled out of the building was added on. Yeah? So again, it's a conversation between the machine and me as a designer. I'm not relying completely on what the machine gives me. It's like, oh, I like that, I'll use it, and I add this on. Peter Eisenman once said, like he's like famous as being like super rigorous, right, in designing. But he said one time something I liked. He said, if I don't like it, I change it. It doesn't mean that you have to religiously follow what comes out of the process. The Deep House is another project in a similar vein. This is a commission for a one-family housing project in the Alps in Vienna by a Viennese neurologist. And he found our work and said like, oh, I like the idea that somebody is using results from neuroscience, which is my field, to do design. So he commissioned us with creating a summer house for his family in the Alps. But he had one condition. He said it has to be a mid-century modern house. That was like his condition, it has to be. And I said, it's no problem. We just took like tons and tons of facades and sections and plans from mid-century modern houses, created our own data set, ran it through StyleGAN 2, tweaked the weights, like the same thing we did before with the General Center. But this time, the pixel projection created some quite interesting results. There's always the problem when you work with AI that most cases, most techniques either give you a 2D plan, section, elevation, image, or they give you, if you work with 3D models, for example, in AI, it gives you either an exterior or an interior, but it cannot work on both things at the same time. The human ability to understand that we're sitting in a room that actually has an outside facade and that there's an outside world is something that AI does not process yet. It can only process limited elements, like an interior, an exterior, and so on. It might do that in a while, but at the moment it cannot do it. In this case, we actually got a result that was an interior and an exterior at the same time, which was for us very exciting. Oh, and yes, and then we started to continue working on it, creating mid-journey imagery for more details of the interior. Yeah, that was actually quite an exciting project. And then the doghouse, it's kind of it's a model, sort of, but it's the first time that we take it out from being just images and plans and representations to something more physical. I'm gonna just run this video. I don't know if we have sound. It's okay, I can tell you what you're seeing here. So this was sorry for the interruptions. I don't know where this is coming from. Maybe it's the cable. Yeah. I'm sorry for the interruptions. This is going on for a while now already. Just gonna try to, don't know what's happening here. Anyways, it's an exhibition design for an exhibition in Vienna for an exhibition that was called /Imagine. And you might know this is like the first thing you enter in Midjourney. And it was a group exhibition, I think like 8 or 9 people, like showing art around AI, and we were the only architects. No, there were like 3 architects, I think. And we did the same process I mentioned before with the Deep House and the General Center, like StyleGAN and a variety of images. In this case, we used actually Midjourney to create sections, and then took these sections and created the pixel projection to make a model, and then we fabricated it. For us, it was important to showcase that it's not only about the images and pixels and 2D, but actually you can build something with it. So this was the first attempt. It's just a doghouse, it's small, but basically you can do this big too. And it was populated by a couple of robotics dogs. That's why it was called the doghouse. Volleyball mentioned that I was wearing like weird glasses. That's what we used it for volleyball. We built stuff with it. Yeah. And we used it to build it up, which was really very practical. It's identical to the 3D model. And because of the use of augmented reality, it was also possible to do it fast. We're experimenting at the moment to combine augmented reality with AI for construction workers to see, for example, mistakes on construction sites. So there's practical applications where you can combine a variety of different methods. You can use artificial intelligence for machine vision so that the machine can recognize errors or things going on. and you can use augmented reality to transmit that information to human workers so that they can react fast. And in the background, we had like a huge print, backlit. It consisted of about 30,000 AI-generated images that from a distance looked like a gradient of color. This is, by the way, an art piece that we're doing a similar art piece right now for the Max Planck Institute in Munich. Yeah, that you see in the background there. So again, what I want to say with this is how do you push that out of the two-dimensional to something 3D? I'm really looking forward when we build the deep house, because that's going to be, I think, the first build object based on this technique. I think the first project we built with AI was the robot garden. The robot garden opened in 2021, and as far as I know, was the first architecture project that was built that used only AI for the design process. So again, first a mid-journey image, then we cleaned it up to get a nice pixel projection, then we made the pixel projection and built the object. And this is a quick view of the fabrication elements of the doghouse. We needed to reduce the amount of panels, and we also optimized it for reducing the material consumption. So from the first model that we created with the pixel projection to the final product, we saved 60% of material. So the first result was not optimized, and then we iterated through a variety of optimizations to make sure that we consume as little material as possible when we build it. So this was the rendering of the final model, and then this was the assembly. And this was the day of the opening. So there's like 2 guards, myself running around the thing with the robots in the ground floor playing around. Children loved it. They were like all the time playing around with the dogs. And there comes the visitors. Yeah, robot-human interaction. So apart from the projects and exhibitions, publications is a major part of my work. To be honest with you, I was waiting for a long time for somebody to write about what I'm interested into. I've always been a big admirer of Jeff Kipnis and Sanford Quinters, these 90s theorists. But no one came around writing about what I wanted to read. At some point I was like, okay, I'll do it myself, whatever. Yeah? So I started writing books. I have to admit, in my former life, before architecture, I was a journalist. So at least a little bit about writing. So I tried to implement like all these ideas that came up to me. And it was for me also important to show the work of others. Because it's not just me doing that stuff. There's like a whole group of people around the world who are really interested in this kind of work. And we regularly meet. We have Zoom meetings. It's called the Neural Architecture Group, NAG. And we talk about all those topics. And when I get the possibility to publish, I publish their work and my own work and try to create what I mentioned at the beginning as sort of a discursive frame for all these things that you're seeing right now to make sure that we are not left behind also theoretically as architects. Yeah? I think it's important to understand that all of this makes a new theory possible. Yeah? So this was a book only about diffusion models, only about all these kind of pixel-based things. And for me, it was interesting. I invited 20 architects and 5 theorists to write in this book. And the architects are told, it's okay if you just send me images. Yeah? I didn't expect them to write anything. I gave them the option to do it, but it was like, it's fine if you just send images. The book is basically just to look at images. Every single architect insisted on writing an essay about it. Like, because it makes people think, how it changes design, ecological work, engineering. So it obviously makes architects think, and they were actually quite thankful to get a platform to express this. The whole design of the book was made in Midjourney. It took me like 2 hours or 1 hour to come up with the layout for it. Yeah, it sounds fast, right? Yes, the images in Midjourney were done in 1 hour. translating that to a working InDesign file took 2 weeks. So the work does not stop. And right now I came actually to Bangkok to finish this book here, The Architect's Manual to Artificial Intelligence. This is a book that combines like all the possibilities of different algorithms to work in architecture with like a theoretical part that explains how it's tied to architecture history and theory, one part that explains the possibilities, like there's literally like a list of how you can use it in architecture, and code examples. There's like for every single model, there is one box of a Python code that you can copy and paste and start to work with. Yeah? It's a massive amount of work. I've been working on this book for 3 years now. It's still not finished. Yeah? I hope that I can finish it while I'm here, because I think, see like all these red reference things here, then this is where I'm now. Oh, I have to put in the references, important. And just as a fun thing at the end, I made this like a week ago for New Year's to send out to friends. It's amazing how AI can just generate video out of one image. This is quite impressive for me right now. I mean, this was literally just still images, and I added the prompt, people celebrating New Year's, and I got this. So it's quite impressive what it can do by now. Or taking older images and just making videos out of that. So it's really like part of every aspect that you can use as architect. Which means AI is here. So now what? Thank you very much. Ooh, I forgot one important thing. Sorry, 1 second. If you're interested in studying anything like that, please join me at the MS-ACT in New York. I'm creating a specialized master in architecture and artificial intelligence. It's only 1 year long. So if you need an excuse to come to New York for a year, here, I can give you one. We have regular sessions of information. Just go to the website of the MS-ACT in New York. You can sign up for one of the sessions. I think we have like 6 sessions this semester. And I can give you much more details about what they're doing and how we're doing and so on. But I think you got it in the lecture where it's going. Yeah? All right. Thank you. Sorry for that interruption.
Yes.
Questions? Yes.
Hi, Matias. My name is Patricia, and I'm a practice architect.
Mm-hmm.
And I'm quite don't understand what you say about that. AI doesn't understand anything.
Yep.
But they can learning quite good.
Yep.
And what is the purpose of their learning? Not to understand, or just to analyze, or you understand?
I understand.
Question?
Yes.
Okay.
There's different purposes for it. I mentioned in the lecture that AI can do 2 things really well: prediction and optimization. These are the things it does. So, for example, if you wanted to learn how to reduce the material consumption in your design, you can do that. You can say, this is my design. Now, give me options that will use 40% less material. And by looking into many, many other examples that are out there, like architects do, we do this too. We look to other examples. The machine can learn, if I combine this with this and this, I get something that is very, very similar to what you gave me, but with less material. So when we go into architecture education, we learn by looking at examples, right? You see like, okay, Eiffel did this, Renzo Piano did this in terms of engineering, Foster's office does, whatever. We look at these examples and we combine all of that in our brain. And that at the end somehow changes into what is our design. But it's influenced by all these things that you learned in the past. AI does something similar. It looks into the examples and then deducts out of those examples something that can be useful for you as the designer. That's the learning process. It's similar to human learning.
So in terms of architectural design, there will be us as architects
Mhm.
and our clients,
Yeah.
who is maybe developers or laymen. Does it really need AI to understand it, or they just need the solutions that will be enough for our clients
Mhm.
to make use of it?
Yeah. I mean, honestly, I think that the problem with AI understanding anything has to do with the fact that we do not know, in terms of in terms of neuroscience, how understanding works. Yeah. If we would know how understanding or forming a thought in our mind works, we could replicate it and put it into AI. Yeah. But we don't know exactly how it works. Right now, I think AI can be useful for us designers because of the learning process, because it can fast track things that otherwise would take longer for us to do. Like, for example, when we start sketching a plan, we start simple, and then we add like, okay, we have to add here, we have to walk through here, we have to connect this room with this room. This is part of what we learn as architects to understand in the conceptualization of a plan. AI doesn't understand it at all yet, yeah, because it doesn't understand what a living room is or a toilet. Yeah, we can teach it to them, but it's still not sometimes not going to do the right thing. Like, for example, if you're a good architect, you know that maybe I should not open the door towards the living room of the toilet, right? It's not great. So we know that. AI doesn't know that yet. Yeah. Or, for example, sometimes you as a designer want a more generous room. Like, this room is beautiful because it has a high ceiling and beautiful columns and so on, right? And we do this decision intentionally, even if it would be a little bit more expensive to do, because it's the right thing to do spatially, right? And AI would optimize that and say, like, you need here, the ceiling is here, period. Yeah, that's optimization. But I think you can still tweak it and change it and sort of like change the mind of the AI if you want, yeah, in terms of understanding that architecture is more than just optimization.
Maybe it's not enough data for them.
Yes, yeah, that's one of the reasons. Also, who trains it? If a bunch of bad architects trains an AI, you're going to get bad architecture. I think there was a question up there somewhere. Thank you, good question.
So I couldn't make it for the first 5 minutes of the lecture, so would you mind doing a quick recap?
Is this recorded? Maybe you watch the recording? I think it would be more fair to anybody else.
Hi, thank you for the lecture. It was really inspiring. It's a very big topic and very popular topic. So it's really nice to listen to your lecture. So my question is, I think the AI outcome is based on the probability. It's kind of like the most optimized and predict may happen, right? The results. But even though that, then is there any kind of evaluation or verifications, issues or discussions happen? Because I kind of had experience use machine learning processes to kind of integrate to my data set. It's the amazing experience is that I got all the answers, but I had the limitations of explaining the data set and what makes these outcomes happen.
Mm-hmm.
So, I mean, it gives me some probable combination of the elements that would affect on the creating this the set of the data, but still we are not sure because it's based on the probability. So, I mean, even though it creates the images and some kind of design that is still qualitative things, but still possible kind of to think about or discuss about the outcome that really achieved regarding some kind of factors that didn't consider or may happen outside beyond the data set,
Mm-hmm.
right? I mean, architecture, for example, we consider many aspects But when we actually build, lots of other like unexpected factors happen, situations happen, right? So I wonder, I mean, of course it's not, we don't expect like absolute answer, but I wonder whether these kind of discussions happen in the communities of the people working or studying AI.
Yeah, that is a great question. I think this would be like a whole lecture, but I'll keep it short. First of all, what you're asking for is sort of like a general AI, yeah, like a very big AI model, yeah.
Yeah, well, it could be specific, it could be also in general. General, I think people question a lot about how AI accurate it is, but that's kind of common. But
yeah.
For example, if we limit the topic with architecture issues, right?
Yeah.
Architecture, the quality, right? We want to make people feel comfortable or people feel kind of like enjoy the quality of the space. I mean, it's the same question with all the architects doing the conventional design process as well, but we designed based on the AI's suggestions, right? Then can we, have we achieved the right quality or kind of, we achieve the better quality based on relying on the architect experience?
Yeah. I think you need different models to do that. Like you, for example, you would use one AI model for the design and one AI model for quality control that actually basically understands, here we are again with understanding, that basically checks whether what you designed, for example, is up to code. Like, is it up to code? Or that checks whether your choice as a designer for a detail is the right choice. Maybe it provides to you, like, actually it would be more interesting to use this detail because it's better suitable to that environmental condition. So you can use AI really in a variety of ways. You can use it as a creative tool that inspires your work, but you can absolutely use it as a sort of quality control aspect that optimizes towards a good building. Yeah. Oh.
Yeah, I mean, it's kind of like a both way. I mean, use it as a kind of design tool to create, but also a tool can be used to evaluate, like checking the other process the other way.
Absolutely, yes.
Mm-hmm. Okay. I mean, the thing is like a computer, doing simulations was also very popular, kind of give us like really better solutions and advice in architecture design. But it turns out that the simulation results does not explain all the things that are happening in the real world. So what's happening right now is also like a checking, re-evaluating, verifying all the things, which I think is also very important. So I wonder what kind of like AI field will consider this process.
Yeah. And the funny thing is that you're talking about two very specific things. One is using AI analytically, and one is using AI generatively. And the funny thing is that using AI analytically is actually much older than using AI generatively. So what a lot of people see today is a rather new thing versus AI, machine vision, for example, being used for decades already in factories, for example, to check whether the plastic ducts that were produced in an assembly line are nice or not, right? Because, oh yes, this plastic duct looks right. Oh, this plastic duct is missing a head. We're going to put it out. So machine vision as an analytical AI tool has been used for a long time. But the sort of turning around the process and making it generatively is rather something new. And now we're, at the moment, a lot of people are trying to understand how do we combine these two things to create a tool that is very usable for a lot of different areas, not only architecture design, many areas will use that. Car design, fashion design, shoe design, like all of those can use the same tool we can use in architecture, like generative and analytical at the same time. Make sure that the shoe you're designing actually can wrap properly around the foot. That's optimization. Yeah. Does it make sense? Okay.
Yeah, just had one, hopefully quick question. One of your slides showed the kind of iceberg of all of the different ways that AI can be used, and the foundation of that is the kind of data sets that everything is built on. beyond like plans and sections and images, what kinds of data sets are you commonly working with? And beyond like the racial and gender and cultural biases that you mentioned, are there specific issues that you've encountered working with these data sets or ways that you could suggest improving them?
Yeah, so that's a great question. Thank you very much. You have to think that every single thing that produces numbers can be used in AI. Yeah. So if you have, for example, Excel sheets of facade panel distributions that somebody did already in Grasshopper like 10 years ago, yeah, you can take these numbers and then the next time you can actually optimize the way of how these panels are distributed for faster construction or better angling for solar panels, whatever, like what you come up with. So anything that has numbers can be used. Yeah? Or, for example, costs of materials, that's numbers. So if you collect like tons and tons and tons of information about the cost of materials around the world, you can do a lot of things with that. Like, first of all, you can actually analyze how did prices go up and down, and you can use AI to predict how the prices are going to develop in the next year, for example, when you're building that building that you're just designing. And you can then tell the client, it will cost this and this much more precisely. Instead of estimating a number and then having an angry client after a year because it costs like 30% more. Yeah? So does that answer your question?
Yeah, thank you.
Hi, Matias. Thank you very much for a very informative and thought-provoking presentation. I'm Michael Pitt. I'm a professor at the Faculty of the Built Environment at University College London. So delighted to be here listening to you. I'm a bit of a cuckoo in the nest though, because I'm a professor in the School of Sustainable Construction.
Mm-hmm.
And what I wanted to say really was that I'm excited personally. To give you an example, 20 years ago I went on a lecture tour in China with Alan Penn, you may know, and a bunch of architects. I was the only construction person in the group. And as we travelled around China, it became apparent, and I think we all know this, that the connection between architecture, construction, throughout the life cycle of the building is tenuous at best very often. And the way in which you represented the period of occupation as maintenance, I think is indicative of the fact that we haven't quite got there yet. And for those of you that don't know, 80% of the expenditure of a building across the life cycle tends to come in the occupation phase.
Yeah.
So my question would be, do you think that what excites me, that the idea that architects, construction people, facilities people, and maybe even the demolition and replan people, the knowledge that we've all got can be, the sort of team knowledge, can be brought together using AI as a tool?
Thank you for the question. I would just loudly say yes. Yes. I mean, this is exactly what I mentioned before. If we can collect the data about, for example, what you were mentioning, the costs of maintenance, if we get our hands on that, we can do something with that. The biggest problem we, as our laboratory, for example, has, is to get the data. Yeah? Because we know the data exists, but we also know that people just don't give it to us because they're always like, oh, you're gonna make it publicly available. Everyone's gonna see what we're working on, blah, 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 blah. So yes, we can do it, provided people give us the data. Yeah. Let me give you one example how I try to talk to companies that we need to convince to give us their data. What we tell them is, okay, it's a research university, it's a research project, it's a research lab, which means everything has to be public. Yeah? But we can make it in a way that, for example, if somebody wants to work with our data sets somewhere in the world, we can make it in a way that they cannot access the data itself, meaning they cannot copy plans or data out of that data set, but they can only get their algorithm to run through our data set to learn. So it does not have access directly to the data, but only can produce results, which means we protect the data that people give to us. And at the same time, they have the possibility not to work only with their own data, but with the data of a lot of other people, improving what they get out of the result of their AI systems. Does it make sense?
It makes great sense. Thank you very much.
I also interested in the use of the artificial intelligence in the design. But there is I have seen a big like a debate about the copyright when you use the another people design, or it's going to be more on the artist part about when you use another person art to train to do the thing with the AI, and a lot of the people think that the AI like stole their art. What is your opinion about this problem?
Thank you. That's a really good question. I like the question a lot. So, first of all, it has to be made very clear that AI does not copy anything. Yeah, they basically work like we humans do. Like, I know that my designs in architecture are influenced by like 50 other architects or 100 other architects that I've seen through my education, my life as an architect, in exhibitions, in magazines, in books. All of that is somewhere in here. And all of this produces then a design that's like, ooh, that's Matias. Yes, right? So I think that all these artists pretending that, oh my God, my art gets copied. It's not getting copied. Actually, you know what? The funny thing is that if a human artist imitates another human artist, we always think it's a mediocre artist because he cannot come up with his own thing. So if at best AI produces mediocre art, yeah. But I mean, artists. There is artists out there that produce amazing works with AI. Like Mario Klingemann, I mentioned him briefly in the lecture. He uses like thousands of paintings from history, yeah. No one of these artists in this dataset would say that what Matias del Campo does is a copy of their art. No one. So you have to be a creative person to use AI in a way, using other people's work, that's true, but you would do this anyways with your own mind too. So I think artists are a little bit hypocritical about this. It's whining for the whining's sake. Every artist who came to me and complained about the same thing you just told me, I told them, don't be an idiot. Pick it up, use it for your own benefit, and make something interesting out of it instead of complaining about something you have no chance with. By the way, I think every one of those court cases about AI copying artists is gonna go nowhere. So I'm rather for pick up the tool, make something interesting, prove to me that you're a creative person by using it properly and interestingly instead of whining around. Sorry.
Thank you.
Yes, hi. This is Kit again. That was very good presentation. I remember I interviewed you 10 years ago. It was very great. And my question is, the AI, as far as I understand, they are very good with the concept to generate something new for us. But in terms of working with architectures and engineering and facilities, we also working with another dimension, like the dimension aspect of it, space, the length and the width and the height. And the other part is the qualities of it, like the strength of the materials, the textures, and the colors, things like that. So the question is, how long does it take for AI to understand this kind of thing? Maybe in 5 years or in 10 years?
I mean, theoretically, you can do it now. So I think there's two aspects which you mentioned, which I think are important to understand. Number one, I want to debunk the idea that AI can do anything new. It cannot. Like on the pure theoretical level, AI is working with existing data and can only interpolate between these existing data points. Meaning it can create things that look different and interesting and weird, whatever, but creating something profoundly new, I don't think it works with AI. On the other hand, even for a human, producing something profoundly new is exceedingly rare, right? Margaret Bowden, she is a theorist on creativity and AI. She's been writing AI books for decades. She says that there's two forms of new. Yeah, I think she calls it something like subjective and objective. So for example, Kip, if you've never seen the wheel before in your whole life and you invent the wheel, it's profoundly important for you, right? Subjectively speaking, it's incredible. But for anyone else in the world, it doesn't matter because everyone else knows the wheel, right? So it does not have an impact on humanity, only on you. Objectively speaking, if you come up with something that is completely new and no one else has seen before, you have two problems. Yeah? Number one, everyone else will not understand what you're talking about because it's so new. We have no frame of reference. Yeah? And number two, people can forget it very quickly because they don't know what new is. Saying this, for example, the concept of relativity, how Einstein came up with this was profoundly new. And that's how also so many people still don't understand it. Yeah, because wrapping your head around that concept with no reference whatsoever is very difficult. So I don't know if this answers your question, but the thing is that what you were asking for, like understanding all the things around it, I mentioned at the beginning, AI doesn't understand anything, only how we make a frame around it. Yeah? So that's why I say we can do what you're asking for now. We have the tools to do it. We just need, again, same problem as before, the data to do it. That's all I need. I hope this, I'm not sure, I think I went like this, but
Hello, Mr. Matias, please, and Mr. Degree student. And I think that when we talk about AI today, we're going to talk about a generative AI, right? So it sounds like that generative AI will shape how we work in the future, right? So I wonder how about the AI that we use for analysis, for prediction or optimization? What will happen for the next in the future?
I'm not entirely sure if I understood. I think you're talking about the difference between using AI generatively and analytically. Is that right?
Yes. But I think nowadays we talk about early in the generative.
Yeah.
Yes.
I mean, there will be certainly changes. I mean, the tools are getting better very quickly. There's also one problem I'm observing right now is that because the tools are getting optimized and better, they're also at the same time becoming more boring. Because the results are like I call those vanilla models, because they're like, the demand to create very realistic images, for example, has taken away a lot of the strange things that are shown in my images, because it's optimized towards a result that is acceptable generally for everyone. Yeah? And so it's optimized for pop, I don't know. The more interesting way of using those tools is when you can push them to do something different. And for this is where you need to know a little bit about scripting and programming, because that's where you start to change and tweak the things and are not dependent on pre-trained models that are given to you by companies. So Midjourney, ChatGPT, all those models are pre-trained. I mean, GPT, I think what is it? Generative pre-trained transformers. So it's a pre-trained model, which means you cannot influence it in a way that creates something interesting for you as the designer. You have to do your own data sets, your own algorithms, then you can really manipulate it.
Yes, thank you so much.
Thank you, Matias, for your time and your great lecture. Please, everybody, give you a big hand.
Thank you, everybody.
And take a pause with him.
Thank you, everyone.